Hello my dear students, welcome to another PYQ discussion session. In today's video, we are going to discuss the most important PYQ questions related to the topic vernier calipers and screw gauge. And here comes the first question. The question says, 10 divisions on main scale of vernier caliper coincide with 11 divisions on vernier scale. Okay, 10 main scale division is equal to 11 vernier scale division. This is the information that is given in the very first statement. If each division on main scale is 5 unit, that means if one main scale division is equal to 5 unit, okay, the least count of the instrument is equal to what? That is the question. You must understand, least count of vernier caliper is the modulus of 1 MSD minus 1 VSD. 1 MSD means 1 main scale division and 1 VSD means 1 vernier scale division. Okay, now we have got the information regarding what is this 1 MSD, but we don't know about this. So we must get the value for this first. Okay, for that I am going to use this relation. What this relation says? This relation says 10 main scale division is equal to 11 vernier scale division. Now my question is, what is going to be 1 vernier scale division? I repeat, what is 1 vernier scale division? So 1 vernier scale division is going to be 10 by 11 main scale division. It's going to be 10 by 11 MSD. Okay, now I will come back to this particular expression. So least count, as I said, least count is equal to 1 MSD minus, what is 1 VSD? It is 10 upon 11 MSD. 10 upon 11 MSD. Here this is going to be what? Here this is going to be 11 minus of 10 all divided by 11 MSD. Here that is 11 minus 10 is of course 1 upon 11 MSD. This is basically 1 upon 11 into 1 MSD. What is 1 MSD? 1 MSD equal to 5 unit. So here the least count is supposed to be what? 5 by 11 unit, which means option 4 must be correct answer in this case. Now let's move to the next. The question says, given below are two statements. One is labeled as assertion, capital A, and the other is labeled as reason. Assertion says, in vernier calipers, if positive zero error exists, then while taking measurement, the reading taken will be more than the actual reading. This is a true statement. For if there is positive error is there, that means the value what we are measuring is going to be definitely greater than the actual value. Now the reason for that is zero error in vernier caliper might have happened due to manufacturing defect or due to rough handling. This statement is true, but not the correct explanation for assertion. Okay, so assertion is true, reason is also true. I repeat, both assertion and reason are correct, but reason is not correct explanation for the assertion, which means option 2 must be correct in this case. Now let's move to the next question. The question says, if 50 vernier divisions are equal to 49 main scale divisions of a traveling microscope. Okay, so the information says 50 vernier scale division is equal to 49 main scale divisions. Okay, and on the smallest reading of main scale is 0.5 mm, the Vernier constant of the traveling microscope is. So one main scale division is marked as how much? It is marked as 0.5 mm. That is one main scale division. They are asking for the Vernier constant, basically the least count. Vernier constant means least count. Same is the procedure for this one. Again, least count, that is supposed to be one main scale division minus one Vernier scale division, the magnitude of this. So to get the value of one Vernier scale division, okay, I will be going for this particular relation. Okay, what we have 50 Vernier scale division, isn't it? 50 Vernier scale division is equal to 49 main scale division. So one Vernier scale division, that is supposed to be 49 upon 50 main scale division. Okay, so I will be considering that fact here. What is one VSD? One Vernier scale division is equal to 49 upon 50 main scale division. 49 upon 50 main scale division. So we will be considering this over here. So the least count is equal to one main scale division minus, okay, one VSD is equal to how much? It is 49 upon 50 MSD. Okay, now here this is going to be what? 50 minus 49 all divided by 50 MSD. This is equal to 1 upon 50 MSD. That is 1 upon 50 into, what is 1 MSD? 1 MSD is 0.5 mm. Okay, 0.5 mm. How to manage this? You must check all. Here we have got the answer in millimeter, centimeter, centimeter, and again in millimeter. 4 options are here, isn't it? Of course, keeping this as millimeter, if I want to check, of course, here this is going to be what? Here this is going to be 1 millimeter into what I have here is 5 into 10 to the power minus 1 all divided by, I have 5 into 10, that is 50. This one and this one will go. Okay, this will go to the top. So basically this is going to be 10 to the power minus 2 mm. 10 to the power minus 2 mm. How much it is? 0.01 mm. Option 4 must be correct answer in this case. Now let's move to the next. The question says, a Vernier caliper has 20 divisions on Vernier scale which coincide with 19 divisions on main scale. That means 20 Vernier scale division is equal to 19 main scale divisions. Okay, the least count of the instrument is 0.1 mm. Least count is equal to 0.1 mm. Okay, the question is, one main scale division is equal to how many millimeters? I repeat, one main scale division is equal to how many millimeter? That is the question. We all know that how to calculate the least count. Least count is calculated as 1 MSD minus of 1 VSD. This is the standard relation, isn't it? Yes. Now, first of all, let's get what is the value for 1 VSD. Since 20 Vernier scale division is equal to 19 main scale division, 1 Vernier scale division is equal to 19 divided by 20 main scale division. Okay, now let me substitute that here. Least count, that is supposed to be 1 MSD minus of 1 VSD is 19 by 20 MSD. Okay, here this will leave it as 20 minus 19 upon 20 MSD. Okay, here this is least count equals 20 minus 19 is 1 upon 20 MSD. I am going to write this as, now let me substitute the values here. What is the least count? 0.1 mm. I am going to write as 1 by 10 mm. That is equal to 1 by 20 into 1 MSD. 0 and 0 will cancel. Okay, now from here 1 MSD is equal to 2 will come here. So it is 2 mm. Okay, so option 2 should be the correct answer here. Is that okay? Now let's move to the next question. The question says, while measuring the diameter of a wire using screw gauge, the following reading were noted. Okay, main scale reading is 1 mm. Okay, the main scale reading is 1 mm. Okay, and the circular scale reading is equal to 42 division. Circular scale reading, that is equal to what? 42 divisions. Okay, now the pitch of the screw gauge is 1 millimeter. Pitch capital P is equal to 1 millimeter. All right, and it has 100 divisions on the circular scale. Now the number of divisions on the circular scale, I mark it as capital D. That is equal to how much? 100. Okay, now the diameter of the wire is x by 50, then the value of x is, that is the question. So with the given data, first of all we must know how to take the final reading. It's going to be main scale reading plus circular scale reading into least count. This is how we take the final reading. Okay, now to go ahead we must know what is least count. What is least count in the case of screw gauge? It is going to be pitch upon number of divisions on the circular scale. What is pitch here? Pitch here is 1 mm upon 100. So I can write it as 10 to power minus 2 times 1 mm. That is the least count. Okay, now what is circular scale reading? Circular scale reading was equal to how much? 42 divisions. So now it is basically 42 into 10 to power minus 2 mm, or I can say 0.42 mm. Isn't it? Okay, now what about the main scale reading? Main scale reading is 1 millimeter. So the final reading, or I can say the diameter is now going to be what? Diameter is going to be 1.42 millimeter. It's 1.42 millimeter, and you can check here the diameter is marked as x by 50. So basically what happened here is it's 142 into 10 to power, like here I'm going to multiply it with 100 and divide with 100. Okay, so it's going to be 142 into 10 to power minus 2 mm basically. So I can mark it as 142 upon 100 mm. Okay, now if I divide like it with 2, it's supposed to be what? 71 upon 50 mm. Okay, and you can compare your answer here. Okay, it is 71 upon 50, and here it is marked as what? X by 50. So what is the value of x? It need to be 71. Okay, here one part it seems missing, the diameter of the wire in millimeter. Like here it should have mentioned x by 50 millimeters, so that should have made more sense. All right, yes, moving to the next. The question says, in a vernier caliper, when both jaws are touch each other, the zero of the scale shifted towards left and the fourth division coincides exactly with certain divisions on the main scale. So it is the fourth division coinciding. Okay, it is the fourth division coinciding with any reading on the main scale. Now, if 50 vernier scale divisions is equal to 49 main scale division, here 50 vernier scale division is equal to 49 main scale division. Okay, the zero error in the instrument is marked as, what is the zero error? The zero error, it is marked as how much? 0.04 millimeter. The zero error is marked as 0.04 millimeter. Then how many scale divisions are there in 1 centimeter? How many divisions are there in 1 centimeter? That is the question. Yes. Now have a look. Here we know 50 vernier scale division is equal to 49 main scale division. So what about one vernier scale division? One vernier scale division is equal to 49 upon 50 main scale division, and the least count is 1 main scale division minus 1 vernier scale division. That should be equal to 1 MSD minus of 1 VSD is equal to what? 49 divided by 50 MSD. Here this need to be, once I rearrange, it should be what? 1 upon 50 MSD. Are you getting me? Yes. Now, what about the zero error? Zero error is marked as 0.04 millimeter. Okay. And what should be this one? This zero error, that means 0.04 mm, that should be equal to the least count. What is least count? 1 upon 50 into 1 main scale division. Okay, into how many number of, what is the coinciding reading? I mean the coinciding division on the main scale, that is the fourth division. Are you getting me? Now rearranging this, if I take this towards the left, it's going to be 0.4 into 5 mm, that is equal to 1 MSD, okay, into 4. All right, of course this one and this one will cancel. Okay, fine. Now what about 1 MSD? 1 MSD, that is equal to, okay, that is equal to what? Here I am left with 0.5 mm. Is that fine? Is that fine? I repeat, 1 main scale division is equal to 0.5 mm. Now my dear student, please try to understand the situation here. Let this be 0. All right. Now here this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here this is 1. This is 1 centimeter precisely say. So here this is 0, here this is 1. Okay. Now what is this? Here this is 0.1 centimeter, or I can say it is 1 millimeter. Okay, I repeat, 0.1 centimeter or 1 millimeter. So what's the least count here? Here the least count is 0.1 centimeter or 1 millimeter, or I can say 1 main scale division is equal to 1 mm. Okay, now consider a situation where I am going to further divide it like this. Okay, I'm further dividing it like this. Now what is this reading? This reading is 1 mm again divided by 2, that is 0.5 mm. Are you getting me? Now this is the new value of 1 MSD. So new value of 1 MSD is now equal to how much? Dear all of you, please tell me. It is 0.5 millimeter. Okay, and tell me how many divisions are here. Earlier it was 10, now it is 20. So the answer is option 3. Was that fine? Now let's move to the next. The least count of a Vernier caliper is 1 by 20 centimeter. Okay, least count is given as 1 by 20 centimeter. The value of one division on the main scale is 1 millimeter. That is 1 MSD is given as how much? 1 millimeter. Okay. Then the number of divisions of main scale that coincide with capital N division of Vernier scale is. Like how many divisions of main scale is coinciding with capital N division of main scale? That is a question. So let me say X main scale division is equal to capital N Vernier scale division. Okay. Now then what is one Vernier scale division? One Vernier scale division should be equal to X upon capital N main scale division. This is a quite familiar relation for you. How to get the value of 1 VSD? Yes. Now what about least count? Least count equal to 1 MSD minus 1 VSD. So considering this, and if I substitute the value of 1 VSD over here, I can say the least count is now equal to 1 MSD minus of, what about 1 VSD? It is X upon small letter x upon capital N MSD. Okay, yes. Now, dear students, what is least count? Least count is marked as 1 by 20 times N. I repeat, 1 by 20 times N centimeter. So 1 divided by 20 times capital N centimeter. That is the least count. Okay. Now, what about 1 MSD? 1 MSD is equal to 1 millimeter. Okay, right? So here this is 1 millimeter. What I am going to do is, let me connect this term now. Here this is going to be what? Capital N minus of x all divided by n. That means n into 1 minus of x into 1 MSD. Okay, 1 MSD is common here, 1 MSD. And what is 1 MSD? It is 1 millimeter. Okay, so 1 millimeter I can write as what? 1 into 10 to the power minus 1 centimeter. Here you know that I can write this here. Basically it is 1 by 10 centimeter. So this 0 and this 0 will cancel, n and n will cancel, centimeter and centimeter will cancel. I am left with 1 by 2 on the left, that is equal to capital N minus of x. Okay, now what is the value of x? X is supposed to be capital N minus of 1 by 2, that is 2n minus 1 by 2. It's 2n minus 1 by 2. That means option C must be the correct answer in this case. Alright, now let's move to the next. There are 100 divisions on the circular scale of a screw gauge of pitch 1 millimeter. Okay, so the divisions on the circular scale is how much? It is 100. I repeat, it is 100. And what about the pitch? Pitch capital P equals to 1 millimeter. Okay, yes. With no measuring quantity in between the jaw, the 0 of the circular scale lies 5 divisions below the reference line. 5 divisions below the reference line. So my dear students, please try to understand the situation here. In normal case, this is supposed to be 0 and here this is supposed to be 0. Here this need to be 1, here this need to be 2, here this need to be 3, like that, and here this need to be 99, here this need to be 98, and here this need to be 97, like this, where there is no 0 error. And now what happens is, as per the question, 5 divisions below the reference line. Okay, are you getting me? See, the 0 of the circular scale lies 5 divisions below the reference line. Okay, which means what is the coinciding figure? Coinciding figure over here is going to look like this. Okay, so here this is going to be 5, 4, 3, 2, 1, 0. That means here, since 0 lies below, there is a positive error of what? 5. I repeat, there is a positive error of 5. So the 0 error is 0 error is plus 5 divisions. Okay, and the additional 5 value will be there. Yes. Now, the diameter of a wire is then measured using this screw gauge. It is found that 4 linear scale divisions are clearly visible while 60 divisions on circular scale coincide with the reference line. So the main scale reading that is equal to how much? That is equal to 4 mm. That's equal to 4 mm because here the pitch, it is marked as what? 1 mm. So 4 mm is the main scale reading. All right. Yes. Now yes, it is found that 4 linear scale divisions are clearly visible while 60th division on the circular scale coincide with the reference line. How much? 60th division, isn't it? 60th division is coinciding. Now what about the circular scale reading? Circular scale reading is going to be 60 minus 5 into the least count. Okay, fine. 60 minus 5 is supposed to be what? 55. Okay, into the least count. Now the point is, what is least count? Least count is pitch upon number of divisions on the circular scale. What is pitch? Pitch was 1 mm and here this is 100. So here this is going to be what? 0.01 mm. 0.01 mm into 55 is going to be what? 0.55 mm. So my final answer is going to be 4.55 mm because I have got the main scale reading as 4 mm. So 4 mm plus 0.5 mm is going to be what? 4.5 mm. Was that okay? Now let's move to the next. The question says, one main scale division of a Vernier caliper is equal to m unit. One main scale division, okay, that is equal to m unit, small letter m unit. Okay, then if nth division of main scale coincide with n plus 1 division on the Vernier scale, that means n main scale division is equal to n plus 1 Vernier scale division, isn't it? Fine. N main scale division is equal to n plus 1 Vernier scale division. Then the least count is, obviously what we'll do here, first of all we need what is 1 VSD, and 1 VSD is equal to what? N upon n plus 1 MSD. And how to get the least count? Least count is 1 MSD minus 1 VSD. That is equal to 1 MSD minus, what was 1 VSD? 1 VSD is n upon n plus 1 MSD. Okay, here this is going to be n plus 1 minus of n all divided by n plus 1 MSD. N and n will cancel. Here this is going to be n upon n plus 1 MSD. Now what is 1 MSD? 1 MSD equal to m unit. So here my final answer is going to be the least count is equal to n into m. Okay, I think n and n got cancelled. No, n is not there. N and n got cancelled, only 1 is there. Okay, so here my final answer is going to be what? Final answer is going to be small letter m upon n plus 1 unit. Okay, m upon n plus 1 unit, that means option C is going to be the correct answer here. Now let's move to the next. The question says, in a screw gauge, there are 100 divisions on the circular scale and main scale move by 0.5 mm on complete rotation of the circular scale. Okay, so here number of divisions is equal to how much? 100. And what is pitch? Pitch is equal to 0.5 mm. Pitch is equal to 0.5 mm. Okay, now the zero of the circular scale lies 6 division below the line of graduation. That means the zero error is equal to plus 6 division. Okay, yes. Now when a wire is placed between the studs, 4 linear scale divisions are clearly visible. Okay, so main scale reading, that is equal to how much? 4 divisions. Okay, while 46th division the circular scale coincide with the reference line. And what about the circular scale reading? Circular scale reading, that is 46th division is coinciding. Okay, 46th division is coinciding. So we need to get what is the circular scale reading here. Now finally the diameter of the wire is, that is a question. So of course we all know that the final reading is supposed to be main scale reading plus circular scale reading into the least count. Now the point is, what is least count here? The least count is supposed to be pitch, that is 0.5 mm divided by 100, that is 0.5 into 10 to the power minus 2 mm. Okay, yes, we have the circular scale reading as 46 division and there is a zero error of plus 6. So the circular scale reading after the error is circular scale reading without error, that is supposed to be what? 40 divisions. Okay, now what about the circular scale reading now? Circular scale reading, that is supposed to be 40 into, okay, 0.5 into 10 to the power minus of 2 mm. Is that fine? Now if I take this 2, it's going to be 5 and 5 fours are 20. So 20 into 10 to the power minus of 2 mm, or I can say it is 0.20 mm. That is the circular scale reading. Finally, what about the main scale reading? On main scale, 4 linear divisions are visible and 1 division is equal to 0.5. That means 4 division is equal to how much? It's 2 mm only. So it is 2.20 mm. Okay, or here I may mark it as 220 into 10 to the power minus of 2 mm. Alright, 220 to 10 to the power minus of 2 mm, which means here the answer need to be what? 220. Is that fine? That was all from my end for this time. We will meet in the next video. Till then, bye bye and take care.